Android is that all the user interface events in Android and all the user interface updates in Android is all done on the main UI thread. So if we do long-running computations on the UI thread, then the user interface becomes unresponsive and can cause a lot of problems, including things like the application not responding to user events. So in order to demonstrate how such problems can arise in an Android application, we're going to implement a simple little application which involves doing a lot of computation on the main UI thread, and we will see how the user interface becomes unresponsive in that circumstance. Subsequently, we'll try to address this problem by using two different methods that Android provides in order to offload the main large amount of computation to a background thread in the form of either using a background thread explicitly and or using something called an async task. So let's begin by implementing a simple application which involves doing a lot of computation on the main UI thread. So let's go ahead and get started by creating a new Android application. We have done this many times before, so we go ahead and say File, New Android Application Project, and pretty soon you will see this screen popping up. Let's call this application as unthreaded, and then the package name, as we have always been using, let's call it HKUST COM4521. As you realize, it doesn't really matter what you name the application. So the rest of the stuff you can just leave it as it is and then create a blank activity, and then we will call the main activity as main and then finish. So pretty soon you'll have the Android application popping up on the screen, the unthreaded application popping up on the screen. Once we have the application ready, then we will go ahead and then modify this application in order to demonstrate some of the problems that we see with doing large amount of computation on the main UI thread. So in order to help us do that, what we will also do is to create a user interface where we can show the progress of the computation as it is happening in the background. How do we do that? We make use of a progress bar on the main UI thread. So let's get back to the main UI thread, and then we will open up this activity main, which is the activity main.xml, which is the layout file. And then in that, because we created the simple hello world application, so we have hello world there. So let me go ahead and change that string to simply say click the button. Okay, and then we will go ahead and center it. We have seen this already before. To center an item, first of all, we'll let it span the entire parent's width. The height will be left as it is, and then we'll set the gravity to center so that it's displayed in the middle, and then make the text a bit more visible by changing that to 18 SP so that text is a bit more clear. In addition, on the text view, what I'm going to do is to put in one more little text view below this to indicate tiny little text view. All that I want to do is for this to say progress, so that it basically displays the progress underneath. And down below the progress, I'm going to drag in something called the progress bar, a horizontal progress bar. So let me drag in the progress bar from the okay, we'll make use of the horizontal progress bar, and then let's center it. And then again, the layout parameters should be adjusted. Let me call this as progress underscore bar. We only have one single progress bar, so we'll say progress underscore bar, and then we'll let it basically fill the entire content. So we'll set the layout parameters for the width. Let's match the parent. And for gravity, let's just set it to okay. This is the view. All right. So for the layout parameters, it doesn't really matter. You can just leave it as it is. And after that, then we will go ahead and include. So this progress bar essentially will reflect the change in the amount of progress that has been made in the computation. So after the progress bar, I'm going to include two buttons down below, or rather bring in a linear layout within which I can enclose two buttons. So I will bring in a horizontal linear layout here down below. We have plenty of space on the screen, so I'm being very generous in putting the space there, and then I'll drag in one button into the horizontal bar, and then a second button also into the horizontal bar. The first one, I will label it as start button. So let's label it as start button, obviously. This is what we expect it to be doing. Start button. So obviously you know what it is going to represent. The start button, and then I would change the text to start. The second button would be a reset button. So let me relabel it as reset button, and obviously the text for this should say reset. Okay, now we have designed a user interface that is suitable for us to represent the behavior of our application as it is going through the different stages in its computation. Okay, now in addition, what we will do is to go ahead and implement the code. So for that, let's save the layout. We'll just go to main.java. In main.java, I already see the stub code in place there. So I'm going to, now that I have included two buttons on the screen, I need an on-click listener. So let me go ahead and include an on-click listener into the code, and then I will import the onClick listener, and then it will complain about unimplemented methods. So we'll just bring in the stub code for the unimplemented methods. Now on the layout, we see three things. We have progress bar. So I will create a variable named progress bar. As we saw, we have the camel casing for all the names. That is, the first letter will always be lowercase, but then subsequently in intermediate you will have capital letters for some of those. And also, let me get a reference to the text view. And one more completed. Obviously, from the name itself, you would be guessing what the completed is going to be holding. That tells you how much percentage of the work has just been completed. So within the code, in the onCreate, I will go in and get a reference to the progress bar. So progress bar, status text, and buttons. So since I have declared the progress bar already, so I would simply go in and say progress bar r.id dot, and then I have the progress bar already in here, so let me get an access to the progress bar in here, and then status text, and we see that we have two text views on the screen. So I will go ahead and then make use of the first text view that is already in place there, because we normally don't want to use the dumb names for the text view, so I'm going to relabel it. So this one was text view 1, this one is text view 2. So I'm going to label this as status text, so that it's more clear from the code what we are referring to. Okay, so once we save activity main, we'll just go to main and then status text, and obviously you will see this crosses there to indicate that progress bar is and text view are unknown, so we have to import the appropriate references to the libraries there. Now let me set the progress bar's properties. So my progress bar, the maximum value it will indicate is 100, basically corresponding to 100%. And the two buttons that I have, let me get the reference to the buttons. Button, so the start button and the stop button. So let me get a reference to the start button, and then I have to set the on-click listeners since I'm going to declare that later. So I'm going to simply say reset button. For the reset button, let me get the reference and then set its on-click listener also. All right, now that we have the references to all the widgets on the screen, let's go ahead and include the code that we're going to execute inside here. So the intention for us was that inside the code, we are going to reference the two buttons, and then also in the on-click listener, we are going to do a large amount of computation, essentially forcing this computation to be done on the main user interface thread. So let me go ahead and implement the on-click listener here. So I would say if source get ID if the incoming source is the start button, then I'm going to do something. We could use a switch statement here if we want, but since I have only two cases for me to consider, so that's why I didn't bother to explicitly. I wanted to show how we can make use of the if statement to accomplish the same thing. Okay, so now what I am going to do is that inside the start button, when the start button is clicked, I am going to make it do a lot of computation in the background. So to help me to do that, let me just use a variable, and then we'll initialize the progress bar, and we'll set the status message appropriately. So I'll say completed is the variable that is going to keep track of what percentage of the work has been completed within the large computation that I'm doing on the main UI thread. So I would say set progress to be completed. So basically meaning that the progress bar is going to be initialized to show that nothing has been completed at this point. So the status text, I'm going to set so this is standard Java for casting a string in place. So basically I'm going to set the text to display the string completed value. Now, after this, what I am going to do is to do a large amount of computation. Now, for us, it doesn't really matter what that computation is. So I'm just going to create the large amount of computation by just using a for loop there. So this is a simple for loop, one inside the other. Basically, this is going to sit around and waste time to indicate that I am doing a lot of work on the main thread. It doesn't really matter what I am actually doing on the main thread. So inside the main thread, I am going to do a large amount of computation, meaningless computation here at this moment. Now, every so often, because notice that the outer loop is running from 0 through 100, so every time one single iteration of this loop completes, 1% of the stage of the work gets done. So I would have to simply increment the completed value by +1 and then print out the progress onto the screen. So let me go ahead and copy this code, because this code is exactly going to implement that particular functionality, and then I will paste it down here and then say we'll be incrementing the progress, and then because completed is an integer, so I can just simply add 1 to completed and then simply display it on the screen. That's about it. For the reset button, it doesn't really matter what I do. I can simply set the progress bar to 0 and the status text back to the initialized value. So when I reset, I will set the progress bar to 0, and then what I will do inside here is to simply say the same message that was being printed on the screen when you started. And then so I'll just set completed to 0. That's about it. Let's go ahead and save this code and then execute this and see what it does on the screen. So I will run it as an Android application on my device, and then you would notice that when this comes up on the screen, then you will have an application which basically displays the progress on the screen. But notice how this application behaves when it runs on the emulator. So okay, that's not meant to be. In case you find that your Android AVD is not present, then you can simply reset the ADB so that the existing emulator, in case it is not getting used, and then when you try to run an application and then Eclipse ends up starting a new application, that means that it is not able to access the other AVD that you have just started. So in that case, you just go ahead and reset the ADB. For that, we need to use the DDMS perspective. So if you want to get the DDMS perspective, simply click on this button up here, and then you will get a list, and then choose the DDMS perspective on the screen, and then it should work just fine. Okay, now sometimes your ADB doesn't start up properly. You do a couple of trials before it gets out and running, up and running. Okay, now when you see your emulator listed in the devices, that means that it's perfectly fine. So now go ahead and launch the application, and it should run on the emulator that you just started some time ago. So when the unthreaded application runs on the screen, you would notice that it comes up with the two buttons. Let's go ahead and click on the start button and watch what happens. When I click on the start button, notice that you hardly notice any progress on the screen, although in the code we actually implemented things correctly. And also notice that the start button, the user interface has stopped responding. So any further clicks to the user interface, you don't see anything happening on the screen. So basically what has happened in this particular application is that it got in, when I clicked on the start button, it got into this on-click method, and then it got stuck in this large for loop where it is doing a lot of computation, and essentially that makes your application unresponsive. And then if your application doesn't respond for a period of time, this is what you will see popping up on your device, basically meaning it is not responding, and so on. So the primary reason for that is that because we are doing a large amount of computation on the main user interface there. This is inappropriate to do in case of an Android application. You should never do large computations on the UI thread. So let me go ahead and then terminate that application, and then we'll then go and try to fix this problem by using a background thread and offload the work to a background thread. Now, whenever you offload work to a background thread, if you want the background thread to periodically update the user interface on the screen, notice that the main UI thread is the only one that has access to the Android's user interface. So any modifications that you do to the UI has to be done on the main UI thread. So if you start a background thread, then from the background thread, you cannot directly manipulate the user interface. The code to change anything on the UI has to be executed on the main UI thread. Now, in case of Android, there are two possible ways that you can address this problem. First and foremost, you can make use of the handler facility that Android provides. Now, I explained to you about handlers in detail in the lecture, so I'm not going to stress about how or what a handler is and so on. In this case, I'm just going to go back to my application and then fix the main.java in order to offload the work to a background thread. So in order to offload the work to a background thread, first and foremost, within my onCreate, I am going to declare a handler and then set the handler properly. So I would say declare the handler there. This is part of Android OS. And then right here, I'm going to initialize. Now, this handler basically is ready to receive any messages or posts that can be done from any other thread. And once a message or a post is done to the handler, then the handler will take care of handling that work. We have discussed this in detail in the lecture session already, so I'm not going to stress further on that. Now, when I click the start button, instead of doing all this computation on the main UI thread, what I'm going to do is I'm going to offload this work to a background thread, basically. Okay, so to offload the work to a background thread, what I would do is I will be shifting all this work into a background thread. Now, in case of Android, Android basically makes use of the thread support that is provided within Java. Now, how do you create a thread in Java? You simply say thread, and I will name it as now. So basically, I am going to declare this as a worker thread, as a new thread, and then in here I'm going to supply something called a runnable, and then I declare that runnable, and then Android obviously complains, saying that that is unknown. So I have to declare a runnable later on. Now, furthermore, once I create the worker thread, I would start the worker thread by saying worker thread start. Now, this particular thing is a runnable, so I need to create a new runnable of that with that name. So I'm going to go down to the bottom of this page, and then I'm going to create a new runnable, private runnable. Okay. And when I create a runnable, it will immediately say that I need to create implement a method inside there called the run method. Now, inside this run method, I'm basically going to do all the computation that I just did in the main inside here. So this computation that I did now needs to be shifted into the runnable, so that this will not be done on the main UI thread. So I'm going to get rid of that from there and then bring that code into the runnable. But of course, this is not going to fix the problem completely. I'll tell you why. Now, also this integer variable that I declared, that I'm going to bring it in here so that the problem is solved. Now, what is the problem with doing something like this here? The problem is that in this particular code, if I simply put it this way, then this updates to the user interface, as I see here, will end up being done inside this worker thread. Unfortunately, as I mentioned a little bit earlier, Android does not permit any background threads to directly manipulate the user interface. Any changes that you want to do to the user interface always has to be done on the main UI thread. Now, how do we solve this problem? Now, fortunately, in case of Android, we have created the handler already. So from any background thread, I can simply post a message to the post a runnable to the handler, and then whatever code is included inside that runnable will be executed on the main UI thread. So instead of doing these two statements inside this background thread, I simply have to shift those statements and ask it to be executed on the main UI thread. So the way I would do it is, I would say handler post, okay, and then it would immediately say a new runnable in this particular case. Okay, so now this part of the code, I should be doing it inside the runnable. So as you see, I have enclosed it inside the runnable. So I've enclosed it inside the handler post. Now, but this code that I want to execute has to be enclosed inside a runnable here. So I am going to enclose it inside a runnable there. Not only that, a runnable cannot be directly used. I would have to create a run method. Sorry, what I was going to do was to only do the updates that I need to do on the UI inside the runnable. So I only need to enclose this part inside the runnable. So handler post new and then this should be inside the run method in here. So these changes that I'm making should be now. When you see any formatting to be made, you can select everything and then click on Control I on in a Windows machine or Command I on a Mac in order to automatically format all of these. So if you are picky about the way your code is styled and set apart, then that's a good way of properly formatting your code. So I have basically enclosed the updates to the UI inside the runnable, and then I'm posting it through the handler post onto the main UI thread. Now I should do exactly the same thing for these two statements out here. So I'm just going to go and copy this code from there and then replace these two statements here with that copied handler code in there. And then it should all work just fine. So let's go ahead and deploy. Now this is no longer called unthreaded, it's going to be called threaded. And so let me go ahead and rename the application as threaded. Okay. Let me rename, and then instead of calling this unthreaded, previously it was unthreaded, now I'm using a thread, so I'm going to rename it as threaded application. Okay, so let's go ahead and execute the threaded version of the code and see what it does on the screen. Now the layout is still the same. It's exactly the same layout. Now let's go ahead and click on the Start button. Now notice how the progress bar is indicating the completion of the work step by step as we go along. So this is an interesting modification to the unthreaded application. So it is now going to be the threaded version of the application. And notice that the progress bar is nicely updating on the screen, and the UI is not stuck or being unresponsive in any manner. So this is one way you can turn an unthreaded application into a threaded application by simply making some change to the code in here. Okay, now another way of achieving exactly the same thing is by using something called as an async task. Now, how does an async task work? In an async task, the Android designers decided that doing work in the background is an often repeated pattern that people use when they are implementing code. So they decided to provide a very nice and easy to use support for doing work in the background, such that the application designers do not have to be too much concerned about creating background threads and so on. So that is where the async task comes to our rescue in providing a nice approach for implementing the same solution in a more elegant way within our code. Now, when we implement it as an async task, so let me go ahead and rename this application as async application. So I would simply rename this as async, so that the new version of the application, I would simply take the code that I have already done before and then modify that to show you how the same thing can be achieved using an async task. Going back to main.java, when we implemented it as a multi-threaded application, I had to use a handler, and then I had to post any updates to the UI from the background thread using the handler.post and so on. So this is a bit cumbersome to use in situations where the pattern of posting updates to the main UI thread from the background is a common repeated pattern. So instead, as I said, async task provides a much better way of achieving this. So I'm going to remove the handler from my code because I don't need it anymore. Instead, what I would do is that the runnable, instead of using a runnable, I'm going to turn that runnable into something called a async task. So I would say private class. I'm going to come back to explain what it does. Worker task, which is of the type it extends async task object. These are the parameters that come in for the async task. Okay, now when I implement the async task, now what happens is that first and foremost, it's going to say that async task is undefined, and then also ask me to implement unimplemented methods. So some of the unimplemented methods is the one unimplemented method that I need to implement for the async task is what we call as do in background. Okay, so the do in background basically will execute the large amount of computation that I was doing earlier in the background. So I'm going to take the large amount of computation that I was doing in the background and then shift it into this task called as do in background. Okay, now I am not going to be using handler post. Instead, I would be doing something called publish progress. We're going to come down to explain how publish progress works in practice. Now, I'm going to shift my variable up there. Okay, now, so do in background basically is executing the work that has to be done in the background. In addition to do in background, there are a few more methods that AsyncTask supports that are very useful for us. So I would say override methods. Okay, and then I would say on pre-execute and on post on progress update. And I don't need on post execute anyway, but I'll just include that code in there. Now, in on pre-execute, the code that I enclose in on pre-execute and on post-execute will be executed on the main UI thread. Similarly, whatever code that I enclose in on progress update will also be executed on the main UI thread. Okay, so these updates that I was doing to my user interface, that I can now basically cut and shift it into the on progress update. Okay, because whatever code that I enclose inside the on progress update will be done on the main UI thread. So I need to remove the now obviously this is not a thread anymore, so I have to remove the on the run method also. So I'm basically shifting all the code from the run method out, and then I'll cut out the code of the run method, because this is the async task is not a thread. Instead, it is a special class that is supported in Android. So, and it provides these four methods. So on pre-execute is going to be executed when my async task begins execution, and this will be executed on the main UI thread. And then similarly, on post execute is also executed on the main UI thread. Whenever I want to update the user interface, all I need to do is call this method called publish progress from the Android framework, and then that will cause the Android framework to call this method called on progress update, and anything that is included inside that method will be executed on the main UI thread. Okay, now, so what I have basically done is shifted all the work into all the large amount of computation into this method called the do in background, and the remaining two into the pre-execute and the post-execute. Now, getting back to this particular code here, previously I was declaring a thread. Now it is going to be called as a worker task. So I'm going to declare a worker task here. Okay, of the type worker, and then inside here I'm going to come in and then say worker is equal to new worker task. Okay, so basically that helps me to create a new worker task, and then when I have a async task declared in the background, I need to start the async task. For starting an async task, the way I do that is to say worker execute, and what is going to make my async task start in the background. So let me go ahead and save the code, and then fix a couple of values in the strings.xml. Let me just check. The app name should be now async. Because that's what I used for my app name. So let's go ahead and execute the async task and see exactly what it does. Now the behavior of the async task should be very similar to the threaded implementation of this code that I showed you a little bit earlier. So for the async task also, again, notice that the user interface is exactly the same as before. Now, when I come in and click on the start button, notice that the UI is being updated at regular intervals as the work in the background is progressing. So this basically shows you how you can implement a large amount of work to be done in the background by using either threads together with a handler or by using an async task. So this is the next part of this is the next lab exercise that you're going to complete in the lab to learn how to do multi-threaded applications. Now later on, we are going to make use of some of these functionality within our music player application in order to address some issues of doing work in the background for the music player application. Okay, so that completes this particular lab exercise.